Summit here in Taipei. Please make sure you find a comfortable seat and we'll get started. So, first I would like to invite Mr. Junshou Lin, the Director General for the Administration for Digital Industries, MODA, to the stage to give his opening remarks. Please welcome Mr. Lin.
Good afternoon, everyone. I'm Junshou Lin. I'm the Director General of ADI. First, on behalf of ADI, I would like to welcome all the participants to this summit. And I also want to say thanks to distinguished speakers from Japan, Mr. Toyoshima and Mr. Kenimoto and Mr. Yoshikawa. Yes. And we also have a distinguished speaker from Poland, Mr. Ostafio. My pronunciation is right, okay. And from domestic, Dr. Cha, and we have Mr. Liu and Mr. Yang for your sharing of your insight in this event. And we know Taiwan is famous for its semiconductor manufacturing industry. And Taiwan also is a strong partner for global ICT supply chain. I think this laid a strong foundation for the development of satellite application and the solutions. So today we invite experts from Japan to share, if I remember, NTN promotion in Japan and how to use AI to analyze satellite data. And from Poland, you want to share EU's perspective on satellite projects. We also have three experts from Taiwan to share their experience and insight in this field. So I hope everyone here can gain some valuable insight from those experts sharing. But finally, I would like to say one more thing. That is a promotion announcement. We just launched satellite application competition several days ago. Please join us. Thank you.
Thank you, Mr. Lin. Please stay on stage. And I would also like to invite the following people to the stage to take a group photo. Mr. Morio Toyoshima, the XGMF NTN Promotion Project Leader, Director General of Wireless Networks Research Center, NICT. Mr. Toyoshima. Ms. Harriet Lin, Senior Vice President and Director General, Institute for Information Industry. Mr. Naruo Kanemoto, CEO, Spaceshift. Mr. Chongyong Cha, President of Chonghua Telecom Network Technology Group. Mr. Marek Ostafil, Co-founder Smart Secure Networks, Polish IoT and AI Cluster, Sinotype. Mr. Cha Kai Liu, CEO of DSP Inc. Ms. Agnieszka Wasut, CEO, Smart Secure Networks. And Mr. Paul Yang, Assistant Vice President of Ubicon Technology. We have a lot of different cameras, so it'll take a second. Last one. If I could ask you to return to your seats, we would like to take a big group photo with everyone attending today. So if you could come back to your seats, please. Thank you. So we'll now take a big group photo of everyone who's attending today. If everyone can give a big smile, a wave, thumbs up, heart, whatever you like. Okay, thank you everyone. So now I'd like to welcome you all to the MOU launch ceremony between the Institute for Information Industry, III, and Japan's XG Mobile Promotion Forum, XGMF. Today marks a new milestone for closer collaboration between Taiwan and Japan in next-generation communication technologies, including 5G, 6G, and non-terrestrial networks such as LEO satellites. Together, both sides will foster innovation, build a Taiwan-Japan communication ecosystem, and accelerate real-world applications across the Asia-Pacific region. First, we would like to express our sincere appreciation to our partner, XGMF from Japan. Although Professor Nakao, the representative of XGMF, could not attend in person today, he has kindly recorded a video message to share his greetings and best wishes. Now let's give a warm round of applause and enjoy the video from him.
Good afternoon, distinguished guests, colleagues, and friends in Taiwan. I'm Akihiro Nakao, chairperson of XG Mobile Promotion Forum, XGMF, in Japan. It is a great pleasure to greet you virtually today. First, I wish to express my sincere gratitude to the Institute for Information Industry for organizing this very important event and for your kind invitation to deliver this message. Although I cannot attend in person due to prior commitments, I'm honored to tell you that Mr. Moriya Toyoshima, leader of XGMF's NTN Non-Terrestrial Networks Promotion Project, is representing us at today's signing ceremony. From Japan's perspective, this MOU is more than just a formal agreement. It is a promise to deepen our collaboration and to create a strong, resilient, and innovative communication ecosystem together. Japan has been actively engaging in global collaboration, such as our recent MOU with NextG Alliance to build a global 5G, 6G ecosystem, and our recent pact with the 6GIA to accelerate next-generation wireless innovation. These initiatives show that international cooperation is essential to shape the future of 6G and beyond. We see Taiwan as a vibrant partner with immense strengths in innovation in semiconductors and telecommunications. By combining Taiwan's creativity and strategic position in the Asia-Pacific region with Japan's technical expertise and experience, we can explore joint trials, prototype demonstrations, and coordinated deployment strategies in 5G, 6G, NTN, and hybrid network architectures. I'm confident that through this partnership, Japan and Taiwan can foster a closer relationship and together build a brighter and more prosperous future for our industries and societies. Even though I'm not physically present today, my commitment to this collaboration is determined. I look forward to seeing the results of today's signing and to the concrete steps our teams in Japan and in Taiwan will take together. Let us regard this MOU as a starting point for long-lasting friendship, innovation, and mutual growth. Thank you very much for your attention. On behalf of XGMF, I sincerely hope that Japan and Taiwan will continue to strengthen our collaboration and build a secure, innovative, and mutually prosperous future in communications. Thank you.
Thank you, Professor Nakao, for your kind words of encouragement. Next, we will proceed with the MOU signing and launch ceremony. May we now invite the representatives from XGMF and III to come to the stage. We also invite the Director General of the Administration for Digital Industries to join us as the witness of this signing ceremony. During the ceremony, both representatives will sign their organization names on the tablets, while the Director General will write the infinity symbol, which will be displayed on the screen, symbolizing the launch of an endless collaboration between Taiwan and Japan. We now welcome both sides to sign the MOU. We now welcome both parties to sign the MOU. So with the signing successfully completed, we would like to invite our distinguished guests to stay for a group photo. Mr. Morio Toyoshima, the XGMF NTN Promotion Project Leader, Ms. Harriet Lin, the Senior Vice President and Director General for the Institute of Information Industry, and Junshou Lin, the Director General for the Administration of Digital Industries, MODA. Today's ceremony signifies not only the joint effort between Taiwan and Japan to advance next-generation communication technologies, but also the beginning of a new era of open, innovative, and sustainable cooperation. We look forward to fruitful outcomes that will drive digital innovation across the Asia-Pacific region. Thank you once again for joining us and witnessing this important moment. Our first keynote speaker is Morio Toyoshima, the XGMF NTN Promotion Project Leader and the Director General of Wireless Networks Research Center for the Network Research Institute, NICT. Please welcome Mr. Toyoshima.
So thank you very much for your kind introduction. And ladies and gentlemen, I'm really honored to be here to present my talk today. Thank you very much for your kind invitation. So I'm Morio Toyoshima of National Institute of Information and Communication Technology, as well as NTN, Non-Terrestrial Networks Promotion Project Leader in XGMF. Okay, so today I will present on next generation communication in Japan, NTN promotion project and use cases. So I will I will present this talk because I am leading this project. So here is the outline of my talk. First, I introduce space communication for, LEO mega constellations. And then I move on to high throughput satellite issue. And then I will describe high altitude platforms, hubs. And then I briefly describe satellite mobile direct trend and the satellite IoT. And finally, I will mention about future vision on non-terrestrial networks toward beyond 5G, 6G, based on XGMF activities. So first, let me start about space communications for mega constellations. So everyone knows already, Starlink has almost 9,000 satellites in orbit. So in the past, so already O3B in service, and also Iridium in service. And recently, Kuiper, so Amazon Kuiper launched several satellites up to 100 in orbit. OneWeb has already well-developed, well-distributed constellation completely. But there are many projects, but in the past, there were several canceled projects due to many issues, something budget issue and so on, like Leosat and Boeing and so on. Just a moment. Next, okay. So I want to talking about the LEO constellation trends in Japan. So in 2023, Japanese cabinet decided to fund this kind of project. So this project will prepare several small satellites in orbit and medium satellites in orbit. And also, these satellites will be connected by laser link. So inter-satellite laser link and ground-to-satellite laser link will be tested. So maybe some satellite will be launched soon. So about this project, Space Compass was awarded by this project. So also NICT is participating in this project as a role of preparation of ground station side. So here is the NICT optical ground station system called Hikari Gate. So we have already several optical ground stations throughout Japan, from Okinawa to Kashima Space Center. So we have automatic 40 centimeter telescope. Telescope uses like a parabolic antenna for RF. And also the biggest dish antenna, 2-meter aperture diameter in Kashima Space Center. And also we have a portable ground station on the move vehicle one. So already these stations were prepared, built. So we want to open this kind of test bed worldwide. So we want to call for any collaborator about this issue. So about the high throughput satellites, maybe you know. So in the past, so conventional geosatellite was used, but these satellites have $3,050 per month per megabps, for example. But by using multiple smaller beams, by using multiple satellite technology, so cost could be reduced to 40 megabit per month by using high throughput technology. And also, after that, so very high throughput satellite technology coming up. So this can reduce the cost down to $5 per month per megabps. And also, functional one is geosmall flexible satellites. So they have new technology, phased array antenna, beam hopping, and mitigation of interference, and so on. On the other hand, so geosatellite have, you know, long latency, but on the other hand, non-geo satellite system, how to say, yes. So in ITU, So they don't call LEO satellites, just a non-geo satellites category. So there are two main categories, for example, constellation and formation flight in the future. Everybody knows now Starlink belongs to this constellation, and also Amazon Kuiper. So they will achieve $5 per month per megabps, for example. Very cost competitive. So in the near future, more smaller satellites will coming up, like our stars. This ping-pong size satellite will form something, a phased array antenna in orbit. So there are several high-throughput satellites projects like this in Europe, in United States. So Boeing and Thales Alenia and Airbus, they are doing their big satellites. And also in Japan, we are developing engineering test of satellite 9, which is a hybrid satellite, include optical link and RF link by mainly Mitsubishi Electronic Company. So this is engineering test of satellite 9. So we want to realize next generation hybrid high throughput satellites. So already all flight components we have developed completely. Then now satellite is in the preparation for proto flight test in Mitsubishi company. So this satellite will be launched maybe after 2026. So this satellite can have a capability up to 100 megabps for one user at the Ka band, very higher frequency, and also a flexible function like a beam forming and a flexible frequency allocation technique by digital channelizer. So maybe after 2026, we want to use this kind of in-orbit satellite as a test bed for 5G beyond 5G technology. So we call this now is a next generation space innovation co-creation platform. So this will build a really in-orbit test bed in near future. So this test bed can enable us to demonstrate really digital software-defined satellite technology, and also new satellite and 5G use cases. So geosatellite, ETS-9 now, has an important role in the multi-orbit era. So this satellite can be a multi-orbit hub with hubs, LEO, MEO, many orbits. So about the hubs, high altitude platform station, you know Japan is very active about this hubs system. So you know already, but SoftBank is developing this sun glider hubs. But recently, SoftBank announced they want to use Sky here. So SoftBank will produce a pre-commercial service in next year, 2026, in Japan. And also, Space Compass. Space Compass is a venture company funded by NTT and Sky Perfect JSAT. They will also produce their service next year. So this platform achieved in-flight demonstration between hubs and smartphone in Kenya this year, last March. So this Space Compass is one of the members of XGMF, our NTN promotion project. So they want to produce this kind of hub service. So these hubs forms several cells on the ground. And the important thing is to have a really low latency about this system, because hubs is flying at 20 kilometers, not such a long distance like LEO satellites. So latency is really important for this. And also wider bandwidth communication can be possible. They already tested by using hubs and ground station like this in Kenya, February 2025. So importantly, they want to have the real service in 2026. If you want to collaborate, so please ask us. And also on the ground station side, Sharp Corporation. Sharp is also our member of NTT promotion project in XGMF. They are developing a ground station, Earth station, like this kind of a flat antenna. So they already verified on ships like this and boat. And also they also tested in the vehicle. So the merit is to use this flat antenna, no mechanical tracking there. So all electronic tracking can be done by this antenna. So about satellite mobile direct and satellite IoT, maybe later on another presenter will present in detail, but so you can see many such services. The first one is, Apple Global Star service. They provided iOS 18, so about the emergency message service. So after that, so Link Global and many smaller companies have some such services. So recently, so in Japan, so Starlink provided iOS 18.3. So if you use your smartphone, but if there is no connection with the terrestrial base station, so this can be automatically changed to a satellite node. So user cannot recognize the change of the link, for example. So KDDI, Japanese company, collaborated with this Starlink, so they already in service. And also AST Space Mobile, so they already launched commercial satellites. So they send a video message from the satellite to ground and smartphones. And also there are many the other services, so about the satellite IoT and so on. So, but I know there are several cancelled projects because of, I think, something like ecosystem could not build completely, I think. So this is a really good technology, but we need to think about how we have a good ecosystem for this kind of system. Maybe later there will be a presentation. So I move on to the future vision on non-terrestrial networks toward beyond 5G. So there were two big consortium in Japan in the past. One is 5GMF, so 5G Mobile Communication Promotion Forum. And also, after that, so there was a Beyond 5G Promotion Consortium there. But 2 years ago, they were merged into one bigger forum, XG Mobile Promotion Forum. So this is a really front line forum for the 6G promotion. So main goals of this XGMF will be like this. One is sharing 5G and global information together with international companies and organizations, and strengthen international coordination, and also promoting international industry and academia collaboration like today here. So XGMS consists of several projects. So there is a general meeting and also a management office, but each project is proceeded independently by the independent leaders. So if you can see homepage, so there are many projects, more than 20 projects in the XGMF. So as one of the project, I'm leading NTN promotion project with a co-leader from the SoftBank and the Space Compass. So objective of NTN promotion projects as follows. So to provide a discussion forum on NTN, including hubs and satellites. And we want to discuss, to share some common NTN issue. And also we are examining NTN technology roadmap. I'll show you later. And we are now discussing on requirements from potential users, future unknown users as well. And also, we are thinking a classification of the position of the Japanese companies. We want to promote Japanese companies. And we want to deploy over NTN and the enhancement of international initiatives among Japanese partners and international partners. So this is just one use case. Sorry, really hard to see. So we examined many use cases, for example, from 1 to 19 last year. So this year, we discussed about more 3-1. So we added 20, 21, 22 use cases. So this chart shows, this is Abshisa shows cases, and ordinate axis shows which technology will be used for this use case. For example, broadband aspect and mobile direct aspect, and IoT, hubs, and sensing, mobility, and NTN-TN integration issue, and so on. So just an example I want to explain. One is 6G NTN and NTN convergence and integration issue. So we added from the past slides about this hubs node here. So of course there are several KPIs, throughput, latency, and coverage. We summarized this kind of use case in this chart. And also we add one use case, mobility in ocean by using hubs and satellites. Of course, you know, hubs will have a low latency, good communication means, even for maritime use. And also we added something, just a countermeasure by hubs. So this year we mainly added hubs use cases. So of course this disaster case, so hubs will have many useful means for the suffered people and the disaster area. And also video transmission from drones. This will be one of the good application by using hubs. So this will be some kind of a main use cases in the future. So here is the NTN technology roadmap discussed in XGMF. So you can see 4 main streams. So one is a broadband satellite communication, and next one is a satellite mobile direct, and third one is a satellite IoT, and last one is the hubs. So at a glance, unfortunately, there are no Japanese original project there. So we are now collaborating with the other countries' project. But we have discussed with a Japanese operator and manufacturer in XGMF meeting. So what to do next? So for the moment, we have discussed, so when disaster occur or some national security issue occur, so there are several different heterogeneous networks like a broadband, IoT, smartphone, and voice call. There are many different things. But something happened. These heterogeneous networks should be connected smoothly when something happens. So we try to explore this kind of direction. Next. No change? Okay. So this is one example of network control architecture. So this is NICT proposal. So NTN integration control network architecture. So we call this INCA. So in this case, orchestrator is an important role to control from the different countries, different companies' information. So even now, in the future, there are many different NTN operators, and also 5G core operators, and 5G core center, and so on. But it is really important to connect each other over the companies. So this can enable us to connect smoothly among several different organizations. So we have built a testbed simulation model for this. For example, some 3 different users want to send a different video quality. So, for example, one is a HD video. Second one is a standard SD. And the third one is a low quality video. So it was succeeded to transmit from the user side to the end side. So this can be overcome, this kind of issue. So there is something, Leo constellation node selection even in this system. Oh, sorry. Okay. So we have discussed in XGMF about the future vision. So there are many points, but mainly 4 issues. One is NTN can realize a ubiquitous network, of course. And also we expect a creation of a new industry and services, of course. And also this is a key technology to a greener future. For example, congested traffic area can be released to a different area. So this kind of things can reduce the energy, for example. And this NTN can act as a good solution for the multi-orbit support in the future. So this is a kind of a picture. So this is an image of the integration of NTN network. So each system have each benefit. For example, terrestrial network will have a large capacity and low latency, of course. And also NTN side will have wide coverage and a dynamic and sustainability for the disaster, for example. But NTN should be used with this terrestrial network. So these kind of complement each other with required use cases. So, but there are some, of course, issues, challenges, problems, of course. So we see now many constellations in orbit. So there are several issues like operation of multiple satellites, you know, frequency exhaust and frequency interference, and also impact on astronomical observers, and something pollution of the satellite by falling satellites, and also space debris issue. So these kind of should be resolved. So, but in Japan, this is personal opinion. So there are many foreign satellites project about NTN. So in Japan, we have to create a new Japanese way or collaborating with Taiwan as something important future services about this issue. So some of these challenges will be discussed in XGMF, our forum activity. So let me conclude as follows. So I explained recent activity on a non-terrestrial network in Japan, and also XGMF about activity in our forum. So due to the difficulty of RF bandwidth, so many constellation NTN such as HAPS and LEO and GEO should be realized to utilize the appropriate frequency for each platform. So it is important for Japan to use, as I said before, hybrid high-throughput satellite technology as a space test bed and demonstrate new satellite and 5G use cases and technologies by, for example, engineering test satellite ETS-9. And interoperator communication over NTN among several different operators. So this will be inevitable in the future. So R&D of the interoperability is highly expected. So I have seen something this kind of topic in today's exhibition hall. So maybe there might be synergy. And also finally, so international collaboration is very important to realize a global high-speed communication network over NTN for beyond 5G and 6G, and also overseas between Japan and Taiwan. So thank you very much for your kind attention.
Thank you, Mr. Morio Toyoshima. Do we have any questions for Mr. Morio? Any questions? We can pass a microphone to the crowd. We have one here.
I have one question. For terrestrial networks, we are very accustomed to that internet allows us to connect different networks from different countries or places. So in the network in space, as you mentioned, the cabinet supported a inter-satellite optical link. Is there any trend that we can connect different constellations or different satellites through inter-satellite communication from different countries or vendors?
Yes, I think there is a possibility. So Japanese private communication operator, Space Compass, tried to make interoperability among different NTN. For example, like a European Space Agency project, Hydron, and SDA specification, which is optical communication interfaces for satellite communication. So they try to do that. So maybe this is a really good point. If Taiwan developed such a seamless interface systems, so we can connect each other. So one country, it is really hard to launch many satellites. So each satellite will have some role to prepare some part of the constellation. This will enable us to make a global network, I think.
Thank you. Thank you very much.
Thank you.
Okay. Thank you. Thank you, Mr. Toyoshima. Our second keynote speaker is Naruo Kanemoto, the CEO for SpaceShift. Please welcome Mr. Kanemoto.
Hello, everyone. I am Naruo Kanemoto from SpaceShift. Thank you for joining me, and I'm very pleased to come to Taiwan. It's one of my favorite country, and So we are developing the satellite data analytic software by AI. So I will present in a very different way how we can utilize the space infrastructure. So firstly, let me introduce my company by video.
Something unusual happening in a distant land. The smallest change that is invisible to the eye. By using space, we can detect these changes. This can help solve problems thought to be impossible. Space can solve Earth's difficult problems. At SpaceShift, we know how to use space. We can combine data from multiple satellites to detect changes on Earth that occur at millimeter units. With AI developed through the combined knowledge of experts, we will find clues that help solve the world's problems. Changing disaster prevention by combining data from Earth and space. If a disaster occurs, social media accounts, drive recorders, and other data from Earth can be combined to provide vital information about floods and other issues with accuracy. Combining the perspectives from Earth and space can bring new information to light. Solving unexpected business issues with satellites. Even agricultural crop growth can be observed. Predicting fluctuations in crop yields can help us understand price movements and also foresee human behavior. From land to offshore, for marketing products, the perspectives of space can be applied to a wide range of business challenges. Finding the ultimate balance between economy and nature. Economic growth and the natural environment, their coexistence can now be considered from the perspective of space. For example, by counting the number of tree species in various regions, we can visualize the CO2 absorbed by the entire planet. From the operations of one factory to the environmental impact of a whole industry, across borders, we can optimize it all. Using space can change how we view the world. Using space can bring us closer to answers to all kinds of problems. With satellites and AI, we can create a new Earth. SpaceShift.
Thank you for watching. So as we presented, we are utilizing satellite data for the different type of application. So I created a company in 2009, so it's already 16 years old company and with 30 full-time employee. And we don't have a satellite, and we are very focused on just the software development. And the space business is expanding. So it's World Economic Forum, the projection of the space industry is going to 1.8 trillion US dollar in 2035. So it's coming to a very big market in the future. And this is a chart. They saying that what kind of a position of the business is in the space industry. So imagining that in the internet industry, we had early age of internet in the 1990s. So you can remember when we had Windows 95 or some older guys knows about the modem, analog modem, they getting just a 56 kilo BPS kind of, that in the 1990s. But we have the broadband connection in the 2000. And then we have broadband connection through the 5G, 6G, and through with the satellite communication to the mobile. So imagining that, the space industry is now like 1990s or later 90s, 2000 in the internet industry. So that is saying after having broadband connection and a smartphone, we had the explosion of the internet, the utilization, like a smartphone application, and everything can be on the internet, and then nobody cannot live without the internet at this time. So the space can be a same infrastructure for human being in these 5 or 10 years. So I'm believing after the completion of the space infrastructure like space internet and also satellite data utilization, which we are involved in, so can bring more big change to the human life utilizing the satellite data in near future. So we are creating the software infrastructure to utilize the space industry. So, and then, so we are utilizing satellite data for the various type of application to create a so-called the digital twin of the Earth. And the so-called satellite data is we can distinguish into 2 types of the data. The one is optical data, so it's very familiar to the human eye. So it has a color and the shape, so it's very normal satellite, the photo that you are always using. But if the weather is cloudy, we cannot see through the cloud on the ground. So it's not the concurrent data for the users. So on the other hand, on the right side is the radar satellite from space. So so-called, we call that the SAR. It's a shortage of the synthetic aperture radar. So that the satellite emits a microwave from space to the ground. So the microwave wave can penetrate the cloud. So we can see on the ground if it's cloudy or night. But the image looks like this. It's black and white, and it's noisy. And this is a picture around the Eiffel Tower in Paris. But on the left image, the Eiffel Tower is there. But on the right image, the Eiffel Tower looks like tilting and a lot of the noises. So it's not easy for human eye. So we created AI algorithm to understand more from the data more than the human being. So we already created the technology to combine these very different type of satellite data together automatically for the lot of different type of applications. And because we don't have a satellite, we can talk to every single satellite company all around the world. So this is a list of just radar satellite, SAR satellite from the world. So we have, the Japanese government have 2 L-band, the large SAR satellite, and the companies and the ESA, the European Space Agency, also has 2 satellites. And on the bottom side, we are having a lot of the space startup company creating the SAR satellite constellations. So we have 2 companies from Japan, so others from America and Finland, and creating lots of the different type of the SAR satellite constellation. But if you talk to the one company, just can provide the 30 or 40 satellite. But if we can deal with all of the existing satellite company, at this moment, we can utilize over 100 of the SAR satellite, and also over 1,000 of the optical satellite already. So satellite is already there, already run in the Earth. So actually, the satellite, this type of satellite is having an orbit of low Earth orbit. So every satellite rotates the Earth in the 90 minutes. So combining all the different type of the constellation together, so we can have every 5 minutes, 10 minutes observation ready all around the world. So this is our approach to make a virtual constellation, is combining all the different type of the satellite constellation together, and creating the automated analysis for these different type of satellites and for different type of applications. So we are not focused on the single application like agriculture or disaster or maritime. We do everything we can do with satellite data. So we already created the algorithm to detect the urban change, like a new building or the destroyed building, or for forestry, we can count the number of the tree by satellite data. And also we do maritime application like ship detection or ocean kind of environment conservation. And for agriculture, we can count the number of the crop, or we can sense the stage of the growth of the crop. And for disaster mitigation, we are having a lot of disaster in Japan and also in Taiwan. So we can do assessment for the flood situation and landslide because of the heavy rain or earthquake. So that can be detected automatically with the satellite data. So the combining all the capability around the understanding of what the satellite data means to the human beings is very significant, and not focusing on just one application, that combining all the change detection by satellite data can bring more insight what's going on the ground. Yeah, so these the chart to show how our algorithm can adapt to the which kind of customer. So we already have a customer in each different field or industry. So later I will talk about every the applications detail. So our expertise is AI, developing an AI algorithm to analyze the satellite data, and it can adapt to any different type of satellite, and developing the very different type of applications. And we, a team of the consists of the AI specialist and the satellite data specialist, can create that very different type of algorithm. And we have a global partnership, and also we already have a lot of the use cases. It's mainly in Japan, so we want to expand that in Taiwan, and with the collaboration, we expand it to Southeast Asia or other territory of the world. And we created, it's Satebiz, is the community of the company wants to utilize the satellite data. So it's a global community, and some of the Southeast Asian companies joining in. And also we want to promote that in Taiwan as well. So most of the company is not related to the space industry. So most of the industry has a relationship or has a possibility to utilize the satellite data for each of the industry. So the Taiwanese company, please let me know if you want to join in this community. It's for free, and we can share a lot of the use cases mainly from these Japanese partners. And yeah, you can join to this community freely. And our business model is we are very focused on just the satellite data analytics software. So we provide that to, on the left side is a satellite company. Now they want to analyze their own data for their client, so they can utilize our algorithm. And also we can get the data from them. And then on the right side is the user side. So we are providing that analytic result directly to users, or we license our algorithm to a cloud or other ICT services. So we are very in the middle of that ecosystem. So the users can find which kind of the satellite data is suitable for their application, or the satellite company can find that good users through our connection, and they can utilize our algorithm to analyze into the information from the satellite data. So that's a very important position to connect the satellite industry and industry users. So now we are very flexible to do business with our software. So sometimes we license the software to the existing platform, or we do the analysis by ourselves, and we provide that to end users, the directory. Sometimes we provide that software for onboard processing. So it's process the data onboard inside the satellite. So in case of the SAR, the synthetic aperture radar data is coming to big, like 2 gigabytes, 5 gigabytes. Is very we needed time to downlink all of the data to the ground. So if we can do data analysis on board inside of satellite on orbit, so we can reduce the volume of the data into a text message. So that's very good application to utilize our algorithm. And this is the ultimate, the final, the picture of the business model. So now we are having over 1,000 of the satellite surrounding Earth, and that's creating the over terabyte of the satellite data already. So those data can be on the cloud servers, and already the most of the satellite data is on the cloud. So we can utilize that satellite data into the application utilizing satellite data. So just with the satellite data, we cannot know the detail of the ground. So we have to combine that satellite data with the IoT or ground-based sensor, the picture, or other data on the ground, and then we can create space data, satellite data services. Now, so we need to have a partnership with the existing ICT company doing the job on the ground with the ground-based data. So all the company has a possibility to utilize the satellite data for existing customer. So this is a very important business model, how we can utilize satellite data for every single application on the ground. So everyone in the venue can be a user of the satellite data. So yeah, please remind that. And this is an example of our algorithm. It's a building detection algorithm. So we can do the new building detection all over the world every 6 days. So we can do this every 6 days all around the world. So we can find a new building in that week, and or we can count new building that has been built in that year. So that can bring a lot of the insight, and we already deployed that algorithm on the multiple platform. And this is a Gen AI based interface to utilize our algorithm. So you don't have to learn about satellite data analytics or satellite data itself. You just ask to the AI about what's going on the ground, and what kind of a change you can detect with our algorithm. So without any special knowledge, you just ask to AI, and then the results came out, and we ran the analysis on the background, and then you can have the answer in a very natural language. So this is already done. So if you have any idea to utilize this type of the platform, so it's already ready to use, and it's not only limited for the building detection. We can run the algorithm for the agriculture, disaster, maritime, everything. So yeah, it's a very easy way to implement the satellite data analytics for your businesses. And this is agriculture case. So as I said, with the optical satellite, we cannot see the ground if it's cloudy. So in agriculture monitoring, sometimes we have a cloud for a month or 2 months, especially in a cloudy area like Japan. and also Taiwan is also cloudy. So in this case, we combine the radar data and optical data together, so we can have a very continuous monitoring of the agriculture. So just with radar data, that you can see that this type of very kind of noisy picture. It doesn't have a color, and you cannot tell that this is a green onion or cabbage. But in this case, it's a green onion. So we do this type of the ground survey by ourselves. So we gather the information from the ground, and we gather information from the space. So we combine those data sets together and creating a very good AI algorithm to detect the crop growth. So as a result, we have this type of the very continuous growth pattern of the vegetable in this case. So these data has been developed with a combination of the optical and the SAR satellite. And just with the optical satellite, you cannot have this type of the continuous growth of the vegetable. So as a result, we can do this type of dashboard. So which paddy had planting in which date, and then we can calculate the harvesting date. So you can have a prediction how much you can have that vegetable in the period, so that can bring more accurate the prediction of the price of the vegetable, or if it's not good, so you can import from others, or you can find out other place to have that vegetable. So this system can bring a lot of the insights to every single the players. So for farmers, they want to know that when the harvesting period, that they can prepare for the harvesting. And for instance, for food company wants to have a more kind of stabilized the price of the resources, or the finding out a new farm or new farmer. So it's there is a lot of the possibility to utilize this type of data. So we are utilizing this approach also in Africa already. So this is a case in Nigeria, and we are looking at the rice paddy with the satellite data. So for microfinancing. So microfinancing bank wants to give the money to the farmers to modernize that agriculture, but they don't know which farmer is good or not. So we can look at the situation of that farming land and going back to past. So then we can see that the farmer is working very good in past. We can give the high credential to give them money, and that reduces a lot of risk for them. So it can expand that business in Africa. So this type of the satellite data analysis that always being done, and we are expanding that business in the world. So I believe the collaboration between the Japanese satellite data company and the Taiwanese satellite industry and the other ICT companies, so can bring lots of the possibility to expand the utilization of space data, satellite data. So yeah, so this can be a very good opportunity to know each other. So please consider to join the SATEBIS community to expand that. And I hope this can be a very good opportunity to know about satellite data, and it's for everyone. It's the next stage of internet, I believe. So thank you so much.
Thank you, Mr. Kanemoto of SpaceShift. Our third keynote speaker is Marek Ostafil, the co-founder of Smart Secure Networks and the Polish IoT and AI cluster, Cenotype. Please welcome Mr. Ostafil.
Ladies and gentlemen, it's great pleasure and honor for me to be here. And thank you very much for your kind invitation and hosting. And I will be happy to present you a little bit different landscape, a little bit different structure, and some of the different challenges that we have, as I will be talking about European approach, but also Polish approach towards the satellite communication. Yes, I am. My name is Marek Ostafil, and I have a privilege to be co-founder and head of international relationship of the Polish IoT and AI cluster, in short, Cenotype. First of all, I would like to give you just a few words about the organization, but then I will be talking more about future of space and how we see it in Europe, and also what type of cooperation we see between Europe, Poland, and Taiwan in this particular industry, and considering also the situation, international situation, geopolitical challenges that we are facing right now with more and more intense. Well, a few words about our organization. The Polish IoT and AI cluster is a nationwide organization. We have built a large network that consists of almost 1,000 different entities. And the aim was to build an organization that will join the forces, that will put together Polish expertise in largely understood Internet of Things supported with AI. So unlike many other organizations, industry organizations, we have many different members. So we do have technology providers, but we also have technology parks as members. We have local authorities. We have research institutes. We have universities, local governments, many different NGOs, many different actors that each of them bring different perspective, different needs, different experience to the table. And thanks to this, we can provide very broad, very large set of skill sets, of experience, both national and international. And thanks to this, we can also have a large portfolio of services that we can offer to our partners. So these are the nominal cluster members, but many of them has their own hundreds of members. So that's how wide and nationwide our network is. We also have created during the pandemic IoT innovation showroom, because as you all know, we were cut off from physical meetings, but then we needed to figure out some way to go out to our clients, to our partners. So first of all, we created the online platform that is available, where we present different types of technology solutions, focus on IoT, AI, but also very strongly on cybersecurity, because we believe that there is no digital reality today without proper security. And later on, we have turned also this into network of showrooms where we present in a physical spaces, we present solutions of our cluster members. Now, we are also very active on European level. We are leaders or consortium members in EU-funded projects. We are members of European Cluster Collaboration Platform. We have also cooperation with Germany, with other European countries, but also obviously in other continents, like Saudi Arabia, obviously Ukraine, but also we are very well connected with Taiwan, closely collaborating, first of all, with Taipei Representative Office in Poland, and we have many different partnerships with Taiwanese institutions, with III, in France. So we are also very grateful, and we are very happy to continue working with III. Now, let's see what Europe is doing right now in terms of space, and especially on SATCOM, in the SATCOM area. Well, obviously, we have different challenges because unlike Taiwan, Japan, or individual countries, we have 20 plus countries to manage the effort, to respond to their different needs, to different level of advancement. So this is quite of a challenge. But for this, we have both European Commission and European Space Agency that are working closely together. And one of the most important projects and programs that we are doing right now is European Space Program that has started in 2021 and is programmed until 27. But most likely will be expanded in the future. Now, it's important to keep in mind that thanks to European Commission and European Space Agency, in cooperation of those two organizations, there are many different space-related or space-focused programs. Some of them are already there. Some of them has been already executed, like, for example, Copernicus, that consists right now of a family of Sentinel satellites, from 1 to 5. There's another Sentinel going to be launched, I think, in November. It's 5P and 5D. And each of those satellites, I will be talking about Copernicus a little bit later. Then we have also Galileo and EGNOS, which is European version, let's say, of GPS. Navigational system. Then we have GovSatCom that is being developed right now, and very, very new one, which is Iris Square, and I will be talking about this also in a few moments. So there are different initiatives, and different member states also are participating on different levels in those programs. Well. One of the biggest challenges right now for Europe and for European member states is security and reliability of the satellite systems. Well, we know that, as it was presented before, right, that the United States, they have a lot of obviously largely developed network of satellites. For example, Starlink, Japan and other countries, they also do have. But then there is this challenge of unifying and putting together European resources in terms of satellite communication and entire satellite industry. Now, we need to, especially under present global conditions and political situations, this need is even stronger than ever. Well, European Union recognized this need of having independent and secure satellite communication already in 2014. Hence, the European Space Program was a result of it. But then it started the project that has the GovSatCom to path the way of creating united European satellite system. So what is also important for us is obviously the Green Deal and digital decade. We all need to think green. We also need to think how to apply SATCOM applications and this technology to foster going green, like monitoring the climate change, for example, but using this, the new technologies in service of sustainability of planet, but also to help us to digitally transform. Right, this is one of the challenges. Also, because different European countries are on different level of, let's say, adoption of the digital solutions. Right, we want to have one single and well-developed digital market, with also broadband internet available everywhere. Right, and if we say everywhere in Europe, it doesn't mean only continent, because there are also other territories, extended as far as French Guiana, for example, that need to be part of the same European network. Now, obviously, what is important factor for our development are different European initiatives and regulations, but also we need them to create the framework for funding, for both for European level funding, but then also for national funding, so those initiatives can be supported by member states. So you see, this is quite complex puzzle, right, that needs to be managed and needs to be managed effectively, providing both security, but also giving the chance for business, to develop and to use these technologies. So we at the same time, we need to satisfy the needs of the public sector, of governments, but also we need to create a network that is very importantly controlled by civilian sector. Because, as you know, the GPS is basically under the umbrella of the US military, right? But then our approach is a little bit different, to create our independent network that is controlled by civilian organizations. So what is very important that I just mentioned before is the Iris Square. This is a quite new initiative that is actually being implemented in 2025 and is extended until 27 and with the programming until 2030. What is going to be Iris Square? It's going to be a flagship European Union project that foreseen to place nearly 300 satellites and connecting them, obviously with development and connection of the ground stations, right? So it's not only development and launching the satellites, but the creating all pan-European network of satellite network, utilizing the infrastructure that we already have, utilizing the satellites that we already have in MEO and LEO constellations. So to provide secure, reliable communication, but also ensure that we will provide the broadband internet in any location of wherever Europe is concerned. So, and this is of course for government use, for public institutions, for different types of organizations, but also for business and individual users. So, so this is very important that we think those two ways at the same time. Another use case that is very important, except the ones that are just more natural, that means environmental monitoring, the climate change, agriculture, maritime, and so on. There is also security of the infrastructure, right, and monitoring it, and this is what we are seeing in the last months, especially after Russia's aggression on Ukraine, and also Russia's provocation that are taking place in the last weeks, on Poland, Estonia, Denmark, Germany, and Scandinavia. We really need to focus on protecting our critical infrastructure. Now, GovSatcom project, it's also kind of part of the IRIS Square, but it's previous project that it's only focused on governmental use cases and needs. And it was like predecessor of IRIS 2, IRIS Square, doing kind of mapping of what type of resources do we have, what type of skills, what needs the public service has in different member states, and to coordinate what do we have, what do we need, you know, what type of use cases every member state has, what we can share, and what we need to develop for the future. Now, this is the GovSatcom project is being created and managed in cooperation of European Commission, but also European Agency for Space Program, EUSPA, that it's also coordinating the side of the training and capacity building that it's needed across all the member states, so they can use, they can bring to the table their skills, but also they can share and they can be trained how to best use the existing infrastructure and the existing technology through competent governmental authorities. So every country has this authority that is managing and it's using the GovSatcom system in every individual country. Now, probably most of you are familiar with Copernicus and Galileo systems. Copernicus is one of the largest, I think, Earth observation systems ever built, right? As I said, we have the entire Sentinel satellite family that is already there. Each Sentinel stage is kind of dedicated to different use case that I will show you in this in a moment. And so, thanks to this, we are able to scan the Earth frequently and also use this data. It was shown also before, you know, in order to manage different use cases for European, but not only European use, because you have to know that obviously the Copernicus is also free of charge service that is available. You can also look it up and see how it works. Now, in terms of Galileo, as I said, this is kind of like our independent independent GPS system, which is also I think more precise than just GPS. And this is why is this also very important for us? We have also noticed in the last months many GPS signal distortion made in Europe, in Baltic Sea, that affects security of flights, of maritime traffic that is caused by Russia. So we really do need independent, more secure and more reliable systems to be able to operate, not to go blind and deaf, you know, in this digital world. And some of the examples of Copernicus, and yes, with the note of Sentinel-5A successfully launched recently. And here are the areas of Copernicus services. So we have, we can observe the atmosphere, all the maritime use cases, land, including obviously the agriculture, climate change, but also these two additional components such as emergency, different types of emergency, like natural disasters, but also security component, which is becoming increasingly important because of European involvement in different military actions, security actions, and those security demands in Europe, but also abroad. And I think that there is also a chance for us to cooperate. I mean, between Europe, especially Poland, and Taiwan. Just a second. Okay, so you see, we have many different tools that are available, many different programs. Now, on European level, it's all managed obviously by European Space Agency. Now, probably Poland is not very well known as a key player in the space industry. And for many years, we have been lagging a little bit behind the space sector, but we are catching up very quickly. And in the last 10, 15 years, we have developed very particular skills, and we have built the space sector that we can be proud of, and also adding to it our ambition, and that we are developing technologies that are unique also on the European level. So let me introduce to you some more of what we do in Poland, particularly in this space satellite industry. Well, the first thing is obvious, that we are fully integrated with all European Union space projects. So Poland has also space agency that is responsible for all the contacts with European Space Agency, that it's responsible for creating policies, frameworks, funding for the Polish space projects, but also is responsible for contribution of Poland to European space projects. So, so this integration is working very well in both ways. We're learning a lot from the joint European space project, but we are also bringing a lot to the table. Our space market, it's growing, and on both in both meaning. Well, first of all, we have nearly 400 companies that are involved in the space industry on different levels, right? So we, not having the launching opportunities, we really focus on making high quality hardware and software systems that are being used for many years already within European Space Agency funded or European funded projects, but also in any other fields of cooperation, like bilateral with Germany, with France, with other European countries. And so this also develops the pool of talents, together with high quality education of our engineers, that it's very crucial for this development. Now, few cases. First is National Satellite Information System, that is like Poland focus Copernicus system. So we use this for managing like agriculture use cases, maritime, climate, and many others. and then you have it. It's also free of charge. It's available to users, and you can also add your products, your solutions to it. Some of the very special Polish technologies like Eagle Eye, Intuition One, and the very new Polish constellation, which is called Camila, which will consist of satellites. First of it was just signed the contract with European Space Agency last month to create our own satellite constellation to support our independence. Intuition One, it's a very particular project by a Polish company, KP Labs, that is focusing on using AI to process images on board of satellites, which is I think quite interesting, and also it's connected with what you were saying previously. Hypersat by a Polish company called Creotech Instruments is our own Polish platform that can serve the building and programming entire satellite mission from launch, control, everything. So we are also quite independent as a project that we can propose to any client, any country, actually to manage the entire satellite mission thanks to this. Now. Obviously, as I said, we are part of GovSatcom project, like most of the European Union members. And few cases, obviously, agriculture monitoring, flood management and monitoring, digital twins, space management. We had last year a strong flood that we were able to use the satellite images to monitor it. Poland was also part of the mission Ignis to ISS very recently. And to conclude, synergies with Taiwan. Well, obviously, what we need is to unite our forces strategically. What we can offer is alignment with EU standards and already the projects that we're doing and sharing our experiences with what we have gained in cooperation within Europe. R&D projects that I think that we can all contribute, and instead of reinventing the wheel, we can just share our experience and move things faster. Interoperability that you just asked before in different contexts, I think is one of the biggest challenges, but also opportunities for us to share our knowledge, but also share our networks. University partnership and knowledge transfer, it's absolutely no-brainer for us to do. And then going deeper, cooperation between Polish and Taiwanese SMEs and startups to build the capacity to foster the joint project, and also to make those partnerships in a very strategic way, in the long way run. That's what I think we need very much to take our strategic paths for development under especially those political and geopolitical conditions. Thank you very much. That will be all for now. Thank you.
Thank you, Marek Ostafil. Next, we have a short break. Please make sure you're seated by 3:30 when we'll have the first of our panel discussions. Exploring market needs and building strategic alliances for sustainable growth. To moderate this panel, please welcome to the stage Chongyan Cha, the president of Chonghua Telecom's Network Technology Group. We also would like to invite up panelists to the stage. First, we have today's speakers, Morio Toyoshima at XGMF, Naruo Kanemoto of Spaceshift, Marek Ostafil of Sinotech, Also participating in this discussion will be Cha Kai-liu, the CEO of DSP, and Paul Yang, the Assistant Vice President of Ubicon Technology. So now I'll invite Mr. Cha to start the panel discussion.
Okay, good afternoon, everyone. And we very precious thanks for Moda. Triple I has this meeting. It's very great. And we hear three distinguished guests have a very wonderful speech for us. Thank you. And we know that Taiwan is a small island, and we need satellite when there's a war between China and Taiwan. Even Taiwan has 20 sea cable over the world. But when the sea cable cut one by one, satellite is the only way for Taiwan for help, you know. So it's very important for Taiwan satellite. So today, we have a speaker talking about NTN in Japan, and also Space Shift company introduce, you have the satellite data for everyone. It's very good for us. And also the Poland have the Europe. You say Europe eye on the Earth, and yes, also in Poland, very good. So first let's start for the Dr. Tomoshima. Okay. Toyoshima, sorry, Toyoshima. And could you share some your thoughts for the international cooperation model and the successful use case, especially for the satellite application, in your point of view? Thank you.
Thank you very much for your kind introduction. So Japan is really same condition between Taiwan.
Yes.
So maybe we can share something common knowledge and to go forward for this kind of NTN or satellite technologies. So just a few my experience so about successful use cases between some foreign countries and Japan. So there was a Satisfy project in Europe by European Space Agency. So maybe more than I think 4 or 5 years ago. So at that time, there was no discussion about satellite and 5G integration, how to use 5G with satellites. But after that, we have learned from European side, and we discussed how to collaborate between European Space Agency side and Japan. So we had concluded some MOU. So our collaboration started. So there was also a consortium under the Satisfy project in Europe, including European SMEs. And also in Japan, we formed a Japanese consortium. So including a satellite operator, satellite manufacturer, and so on. So we demonstrated one typical project. So European side provide 5G core technology, and we provide a satellite node, including G node B, and so on. So we connected each other, so it was successful. We successfully transmitted IoT low data rate data, and also simultaneously we could succeed to send a 4K video by using this satellite node and terrestrial nodes. So this was a really successful experiment between us. And in the future, we want to conduct multi-backholes selection experiment between European Space Agency and our NICT. So just one more good experience. So there was a good researcher in Italy, Taiwan. So we invited this researcher to our organization, maybe more than 5 years, 5 or 10 years ago. So he developed Earth station antenna. He designed this antenna. So then, after I think 1 year later, he come back to Taiwan. I think he did a good new design for this kind of things. So this is also a good experience about personnel exchange between Taiwan and Japan. Maybe this kind of collaboration can contribute to the further new collaboration between Taiwan and Japan. So this is my comment.
Okay, as we know, Dr. Tomashiha is also from Japan, and Japan is the same situation with the Taiwan because they are island. And as you mentioned that KDDI has launched for mobile NTN service to the satellite directly, and it's the first launch in the world, I think. 就是 KDDI 在今年5月，它是全世界第一个operator 可以让手机直连卫星的，在今年5月，它是全世界第一个哈。所以日本，我想跟我们台湾一样，就是 it's the same island, and you want to provide NTN service from the mobile to the satellite. It's very good. And then thanks for the Toyoshima, and then Kanemoto. Oh, sorry. You also come Japan,
yep.
And you have mentioned that you use the satellite data to analyze so many using AI. Yep. Okay. So can you share some your insight, international cooperation model and successful case in your point of view?
Thank you. Thank you so much. Yeah. So we are Earth observation company, and we don't have satellite. So we have to work with the satellite company all around the world. And as Mustafi-san said, the European Space Agency has a program called Copernicus. We use a lot of the Copernicus satellite, like a Sentinel-1 and 2 is a very concurrent the satellite data, and every 2 or 3 days data all around the world. So we are analyzing that open free data into information by AI. So we have to have an international collaboration to continue our business. And on the utilization side, right after my keynote speech, I got a lot of the name card from Taiwanese companies. Yes. And we are very happy to work with IoT, the company. They have in the ground information, and it's easily combined with the satellite data. So this type of international collaboration for the utilization of the satellite data is very important, and we can expand that business in the collaboration with the Taiwanese company and the Japanese companies like us, providing that capability to the Southeast Asia or other territory of the world. So, and also the dual use of that satellite data is very important. I mean, we have a technology to detect the ship. So normally we provide that information for the fishery or ocean environment, but at the same time for the defense and security the purposes, we can provide the same capability to save that the country and the sea lanes. So it's also very important. So I think this type of the international collaboration, getting the data from space and also utilizing the data on the ground. So it's very important.
Yeah, thank you. Kanemoto has said that he's not a satellite company. You use the satellite data to see the Earth and what is the change. It's very good. And you also want to find a collaboration company in Taiwan to have the international cooperation between Japan and Taiwan. It's very good. So it's a very good news for them, and we can cooperate them maybe in the future, I think.
Yes.
Even in the Zhonghua Telecom. Okay. Zhonghua Telecom is right now it was 3 satellites cooperated with Syntel, and also for France, and then for Luxembourg. Okay. Right now we don't have cooperate with Japan, so maybe Zhonghua Telecom can also cooperate with you from your NTN specified in the future. Thank you very much. Okay. And then for Austria, from Poland, you mentioned that there is a project in Europe. You won't have maybe now your eyes to see the Earth and change. So can you explain that? How about the international cooperation between Europe and Taiwan, and what is the challenge between us?
Yeah, so Poland, as a member of the European Union and the European Space Agency, is like natural that we cooperate within European Space Agency projects, but also with NASA. So international cooperation within EU is more than natural for Poland, and it also includes large consortiums, like many partners from different state members within ESA projects, but also there are so many cases that like Polish companies work with German companies, with French, so bilateral for very specific cases. And thanks to this, we were also able to develop very special skills in Poland in terms of satellite industry, like this very high resolution imagery with 1 meter precision, which has been developed by Polish companies, or this AI algorithms and hardware units to process AI images with AI on board of satellite, saving a lot of time and quality and payload, unnecessary payload being transferred to the Earth because of the quality. So you know, we found a niche in which we are really masters, and then we can share that with the rest of the world. But I think there is plenty to be done, and we as a cluster, and thanks to III and hopefully with Zhonghua Telecom as well. But I think what we need right now is to collaborate more, because each of us has experience in some international cooperation. We with European countries within EU, Taiwan with on its own level with Japan. Japan is also with ESA. But I think we need more coordination because time is ticking. You know, there are more and more challenges. So as you ask me about the good use cases of international cooperation, I have one in mind for the next year to see us here with Taiwan as a center hub of Polish, Taiwanese, Japanese space cooperation.
That's wonderful. We heard that. As Tomoshima said that KDDI has launched NTN service in this year, I think May. And what about you, as you know, that Europe, any operator want to in Europe country has an NTN service direct to the satellite?
Well, it's freshly, I would say, it's quite new.
Oh.
I mean, it's there are being done experiments, as you just said. But for now, let's say we have right now, especially in Europe and also in Poland, we put a lot of weight on this new satellite constellation to be independent from third-party providers like US and other countries. So because of the safety issues, security issues, and geopolitical issues that we are facing right now, you know, making independent satellite network is absolutely the top priority for us for the next five years. Yeah.
Okay. As Dr. Tonoshima said that T-Mobile also cooperated with SpaceX in July. In this year, July has a mobile direct to the satellite. 就是 T-Mobile 在美国 T-Mobile 它今年7月也launch这个服务，继这个 KDDI 之后，手机可以直连这个 satellite。Because in Japan and also in USA, the country is very, very large. So maybe some area has not mobile coverage. So when the people want to go to the mountain, climb a mountain, they have no signal for the mobile. So they want to use the direct to the satellite. And as I know, in KDDI and in T-Mobile, is free for the VIP. If you pay more money, or for the operator, it's free for the NTN service.
Yeah, but for example, this project that I mentioned before, the Iris Square, that's European. That's going to be European flagship project to provide broadband internet all over Europe, which is for free.
Oh, yeah, that's wonderful. Yeah, okay. Taiwan is very cheaper for broadband and for mobile. Also, okay. Okay, thank you.
Obviously, in your mobile plan, right? So, so it's like completely for free, but you don't.
Taiwan people want free rate, all you can eat. Thank you, and thank you for the first speaker for those inspiring idea. And then we want to introduce 2 speakers from Taiwan. One is for CEO for 智库驱动 yes, okay. And another is the VP Yang for Yotai. Okay. So can you share some information that open source communication and satellite change? What is the opportunity for you to open data and for satellite data? How do you use the international cooperation between the Taiwan and the international? Can you first from CEO for Liu执行长. Thank you.
Thank you. I was in Europe last week in Spain. I was attending a conference, even with over 1,000 attendees. Even the King of Spain came for the closing remark. And I want to say that after listening to all the wonderful inspirational perspective from the keynote speeches just before the session, before the break, I think I've got a lot of ideas about from the supply side. We've heard the opinion from the supply side talking about, I have this data, I have this communication technology, so what can I do with it? This is wonderful. But what about from the demand side? So we need to look things from the other opposite side. So I think from the demand side, this is where I usually work with. I work with our clients to solve their problems. So they won't say, they don't care what kind of data they need to use, what kind of method they say, I want to solve this problem. How should I do it? That's the starting point. So in order to do that, they need someone to help them to establish the methodology, like the method, the process, or even the data, or even the technology or the tools to use the data. So we are thinking since in reverse, right? So in order to do that, we need to let more people to know about the benefits of using satellite data, satellite-related technologies. This means it's like equal access. We need equal access to data, to tools, and most important, I think it's literacy. We need to educate more people learning about satellite information. But in order to do that, there's a lot of, I think there's a lot of barrier of entry. For example, data interoperability, data standardization, they are all barriers. For example, for SpaceShift, you need to combine all these different multimodal data into one integrated data services. You must take a lot of efforts, right? So, most people will just stop from the first step. They cannot go forward. So that's a problem. And so data standardization is a key. And the second key is we need a more efficient and easy to use way to use this data. Because if like one single file is a 2 GB or 5, it's really difficult for everyone to use. So only the big companies or the experienced users know how to find the proper tool, right? So, but what the users really want is, I'll give some examples. Say, show me all areas in the Amazon basin that has been deforested in the last 6 months, and generate a brief summary in Spanish. I'll repeat it in Chinese again. 给我显示出所有在亚马逊盆地在过去6个月被砍掉的森林，然后并且做一个摘要报告，而且用西班牙文。Okay, so difficult. This is the result the users want, right? But we have to break it down into different tasks. First, we have to identify where is Amazon basin, and what does deforestation means in terms of data, and how do I look for data in the past 6 months, right? And then, after all this is just the data query, and then you need to use this data analysis to come up with the insights and write a summary report in layman's terms. And then you need to, maybe you want to communicate with the local people, so you need to translate into Portuguese or Spanish. See, there's so many steps, so many gaps here. And I'll give you another example. In Taiwan, we just have a typhoon last month. In Tainan area, there's a lot of, because of the strong winds, a lot of roofs are destroyed. And the roofs contains a lot of asbestos roofing sheets, 石棉瓦的屋顶在台南. So I'll give you another example. Identify all the asbestos roofing sheets near schools and generate prioritized cleanup reports. 帮我找出所有有石棉瓦的地方，而且帮我优先排序，在学校附近的，而且帮我优先排序我的清理顺序。This is the problems users want to solve, but still they need to go through several difficult steps in order to get the answers, so they can take action. And so we are talking about how can we create equal access to data, tool, and literacy. That's my first argument. And then in order for the tools, I think AI can help. AI can use to democratize the tool creation, because we are in the age of large language models. We are also in the age of agentic workflow, 代理人的工作流. And in this area, we can, if we can bring the satellite literacy to the target users, they know how to create the tools by themselves. I think this is important. And also, open source is important because I'll give you one example. YOLO is an algorithm for image recognition. YOLO, Y-O-L-O, stands for you build once, you only need to build once, probably things like that. It's created by a research team here in Taiwan. And they started this project in 2015, and it's now one of the most popular image recognition algorithms in the world because they open source it and put it on the GitHub. And right now, last I checked, I talked with the author, they have accumulated, because they already version 1 in 2015, and now it's already version 18. They have collected over 40,000 citations over the years, and also got probably over 45,000 stars on GitHub, and probably 9,000 folks just reuse recreation from GitHub. Means the impact of this open source algorithm is very huge, much huger than a single commercial service can provide. So open source can have a huge impact on democratizing the use of satellite data.
Thank you very much. And as Mr. Kanemoto said that satellite should be like 20 years or 3 years ago internet. The internet is growing. So right now maybe satellite is of a big growing. And in Zhonghua Telecom point of view, we mentioned 4 digits, A, B, C, D. A is for AI. AB speaker say that AI is very important. B is for big data. I think in the future, satellite should be a very, very big data in the future. And the C is the cloud. And use the big data in the cloud, and the D is data center. The cloud should be built in the data center. So AI, big data, cloud, and the data center should be used the satellite combined together. So spaceship should be have many exchange, many opportunity and a challenge in the future, I think. and also 智慧区智库驱动 also has so many opportunity and challenge. Okay, and how about the Yotai VP Yang? What is the point of view for the satellite data and open source?
So first of all, I would like to thank you for the introduction for the moderator. Yes, I'm Paul from Ubica, but today I'm here because I have the other role. I'm the board member of APCC this year. So today I'm here. I represented for APCC Asia Pacific Space Community Council. So this is I think it's the only one organization in Asia Pacific area focused on the satellite industry. So the importance for the open source, I think, here most of experts are talking about application side, and I would like to go back to a little bit upstream. So when we are talking about satellite framework, we all know that they are multi-orbit in the world. Right now we have a geo, MEO, LEO, this kind of three channel. And the most severe problem for the satellite industry right now that is every satellite operator, they are independent and they are parallel. We don't have a universal code to interpret, to implement the information for different operators. So this is something that the 3GPP try to break up. So that 3GPP we will go to the R20 this month. So they try to put the NTN regulation in the R20, but still way to go because we have a big gap starting there. This is the most severe problem for, I think, for the satellite operator, so for the satellite industry to break out the barrier. So this is the other. So this is part of the reason we reflect how important it is for open source communication. Because every operator, they put their data as their own equity, so they don't want to share. So they have their own standard. So we have a lot of application, and we will have a lot of idea how to use, how to interpret those data, and how to help our community, our nation, to more safety, to more efficiency. But first of all, we need to solve the problem how to break the barrier between the different operators. So right nowadays, that probably iDirect, they are open app. Probably will be one of the solution because the iDirect OpenAMP is a main modern source code that they implement for different operators, but they are still only take like a 30 or 40% of market share only. So if we can have a more efficiency over every open source data sharing, then I think for the satellite signal and satellite communications, this will be more efficient and help our whole society. And the application that from previous speakers shared, their idea will be more easier to be established. Yeah.
Thank you, VP Yang. Here's mentioned that APSCC. APSCC is Asia Pacific Satellite Committee. 它是亚洲唯一一个在做卫星讨论的这个会议联盟。那台湾 has two members. One is for Yotai, another is 中华。Okay, so Yotai has a very ambition for the satellite. So you have looking forward for satellite. You want to invest satellite first. I hope that you can successful. Send with 中华。Okay. Okay, thank you. We go together. We all together with Japan and Poland. Okay. Okay, this is the first round. And the second round is the last round. Okay. I would like to ask all panelists that share your view of building transnational strategy analysis. Maybe that sign MOU, have a project, or have a meeting, or any demo between Taiwan and Japan and Poland, and also in Taiwan also. And what is the point of view? And for your vision for the future international connection between Taiwan and your country. let's first begin with Dr. Tomosha. You have slides, right? You have slides for. Okay, you first.
Is this yes. Okay. So I think one country, is it really difficult as one country to prepare mega constellations, for example, you know? So maybe each country can launch some part of satellites. So Japan will, and maybe Taiwan will launch some satellites. Maybe if we can have some alliance or collaboration between us, maybe each satellite can cooperate each other, so they form more global constellation, for example. And also, there is a strong research activity on hubs in Japan. So you know Ishigaki Island, really close to Taiwan, for example. So if Japanese company try to make some new service next year, maybe or later, so maybe it is a really good collaboration among something wireless communication over Taiwan and also Japan by using hubs, for example. Maybe some alliance to collaborate each other will enhance something international really collaboration in the future. So I make an image. So as I said before, so Space Compass company, they are preparing now Japanese rail constellations. So maybe they will prepare maybe around 100 or more satellites, including a geo-satellite node. So everybody understand hundreds is rather smaller really than SpaceX one, for example. But collaboration among several countries will enhance a really global network. So on this ground station side, as I said before, we developed ground station facility. So Space Compass will develop the space test bed, and our side, for example, we develop this kind of facility. So if Taiwan launches some satellites, I'm talking about, for example, optical communication. So Taiwan can use this kind of facility as a kind of one of the ground station, for example, like a site diversity role. And also maybe Space Compass launch some satellites, so Taiwan ground station can do something. So we also, NICT, try to launch engineering test satellite in orbit, GeoNode, but 2026 or later. So this can be also the space test bed. So this satellite can see the Taiwan as well because of the full digital phased array on board. So this can something a platform to test or to verify something ground station system developed in Taiwan, for example. So in the future, like this, so there are many satellite constellations, including Taiwan and Japan, I think. So these could be collaborate each other under some charter or some MOU or some alliance. So this will enhance the global network. And also, as well as these satellites, but about hubs. So Japan will have some new service in near future. So maybe very near close to Japan, Taiwan is really close to Japan. So maybe some kind of alliance and collaboration between these countries. So maybe really low latency broadband NTN service could be realized by using this kind of mutual collaboration. So this is my image of this collaboration. So thank you very much.
Thank you. I like this slide. I hope that Taiwan can have the opportunity to cooperate with Japan, and because we are very close, yes. And Zhonghua also want to have some satellite service and cooperate with Japan. Thank you very much.
Thank you very much.
I like this slide because I have two Japan flag and Taiwan flag. That's wonderful.
Yes.
Okay.
So this MOU is a really starting point, I think. So
sure.
maybe a future,
MOU or some demo or some project we like. Okay,
yes,
thank you very much.
Thank you very much.
Thank you, Dr. Toyoshima. And how about Kanemoto? What's the point of view for the transnational cooperation, and what is the challenge or the opportunity?
Yeah, so as I said, we already have an international collaboration, but more particularly, the Japanese government is creating the governmental Earth observation constellations that with the help with the commercial company in Japan. So we are having multiple governmental constellation for disaster mitigation and the defense and security. So that's gonna be launched until the 2030, for like 50 to 100 of the Earth observation satellite, including optical and SAR. And in this sense, the Earth observation satellite can take data all around the world, of course, in the Taiwan and Japan. And also the Taiwan is about to launch new optical satellite, Formosat 8, made in Taiwan. So that's gonna be the part of that constellation, and we can bring our technology to combine all the different data together, even for the Formosat 8. And that can create a virtual constellation in a collaboration with Taiwan and Japan, and for disaster mitigation or agriculture monitoring, and also defense and security. So it's a very important international collaboration. If we cannot access to the other countries, the satellite, but we can collaborate, we can utilize the Taiwanese satellite and the Japanese satellite constellation together to see the situation, and we can serve that situation with the satellite data surveillance. So yeah, I believe our collaboration is very important for make that country safe together.
Yes. You have mentioned that you want to find some partner in Taiwan.
Yep.
Do you find it?
Yep.
Do you find a company in Taiwan?
Still in the process. Maybe,
the process,
somebody in this venue.
You want to maybe you can raise a hand, and after the meeting,
please come to me and have a collaboration.
I think that you will finally find a partner in Taiwan.
Yep.
And to let the space shift application launch in Taiwan. Thank you very much. And how about our store? What your point of view that transnational cooperation, and what is the challenge and opportunity between Poland and Taiwan?
Yeah, well, I very much like what has been said before, so I just can sign under it. But you're talking. I think this is very important to make something tangible. And as you said about MOU, I was before I came here, I was thinking of creating just a simple working group of all our partners that we can share what each of us has a portfolio of skills, of solutions, of technologies, of experiences. Putting this all together as a working group, and map all the skills. I mean, we know how to do the software, the hardware. Japan has a launching capabilities. So I think, as strangely as it might sound, we already do have all those capabilities to join the forces and to be very independent in a space industry. So, and I like if you, Toyoshima-san, if you can put this beautiful slide, okay, which I like very much, but I would do one modification, okay? And this is, yeah. And I would just, instead of this round circle, I would put white and red, which is Polish flag, and which is also white and red, but then we would have, you know, three partners. So that's what I would just but seriously, I think this really the creation, the working group, the mapping what we have, making this heat map of what we can bring, because each of us has a very particular skills, and under umbrella of such organizations as XGMF, but also with fantastic cooperation of organization that you're representing, right? So we have much larger, and not last but not least, the Junga Telecom that has vast experience also in satellite. I think we really have very strong partnerships. So I would like to invite everybody to form this working group, satellite working axis with a hub in Taiwan between Japan and Poland.
Okay. Thank you very much. So you also want to find some partner to join you?
Oh, well, I think, you know, we are so proud and happy to find a fantastic partner, which is III.
Oh, yes, III.
That's absolutely, we are so honored. So I think, and that's why we are here, and we value this very much. And I think we just can simply extend this cooperation with Junghwa, with Ubicon as well, and your network and other, the Taiwanese, Japanese, and the Polish partner that are willing to join our initiative.
Thank you. Yes, I know that your people is very, very much, 80 million, right? 80.
No, we have 36 million, right? Yeah, 36, but we have, on top of it, we have over 1 million people that escaped from Ukraine after Russia's invasion. So yes, so it's I think 1,300,000 people.
Okay. Thank you. Okay, how about Liu Zong? How about your point of view for the transnational, 就是跨国的合作？然后你认为 what is the challenge or the opportunity as your point of view?
I have participated in several so-called working groups in several different international organizations, like in Geneva or other places. And what we usually do is first we start with setting a list of objectives. In this context, maybe data interoperability, data standards, things like that. And then we start with sharing our notes from all the participants, and then we can start to draft a white paper. This is a UN approach, so that we usually I was in working group for cross-border data exchange. So it's not very different from the interoperator, the data communication. So we start with a white paper saying, in principle, what is the best practice? What are the concerns? And then we will work up from there and then turn into more specific and implementation and the ISO. Next, also in Geneva, just next door near the UN headquarters, they will start drafting up the ISO standards for this issue. And then we have the ISO, so people will want to do the compliance. And then compliance, we need standards, and then we will have a lot of things will gradually become a norm, a common practice. This is an approach in many emerging fields. So what we need in this any forms of alliance, I think we need to start with to get the people of the same interest. So we have some common objectives, and maybe we can start with sharing our stories, and maybe we can discover some best practice or bad practices so we can avoid. And then we can maybe co-create some of the guidelines for going forward. And then maybe we can call for proposals for some kind of a POC, the proof concept projects, and then see where it can take us. That's my suggestion.
Okay. Thank you. CEO Liu is quite young. So I think that your company will lead in the leader and to open source and the challenge for the satellite to cooperate with the other country, like Poland and Japan. Thank you. And how about your Thai VP?
Seems I'm representative of APCC now, so there's no doubt that I fully agree that cross-nation cooperation that is super important. So that's the reason you become a member, and Chong Telecom become a member of APCC, and I take a board member position this year. So I would like to share the other point of view about for the national level, because as we know that due to the geopolitical issue, like every country no less have a independent satellite system is more and more important. Just like it for Ukraine, it's prescribed by Mr. Trump that they will stop to share the Starlink the signal that make a significant trouble for Ukraine during the day. But after this kind of issue, everyone know that have your own satellite system is not only for communication, it's only for your national security. And so it's just show out. But for the for your independent satellite system, we are not talking about GEO. We're talking about GEO, MEO, LEO. We have different orbit. We have different multiple position to cover your nation over your working area. But for this kind of setup, there will have a lot of constraint. We all know that in the space, there's a really limited space to put a GEO. Like every single, we only can put like I cannot remember 204 GEO satellite there, and it's not only because of the position it's quite limited, but also quite the launch of the satellite is really costly. Not only a single country can shoot out like 1,000, 2,000, 3,000 every year. Only for your nation's purpose, because SpaceX they take some advantage as the first one to show out LEO satellite, so they are already dominate the market. But for the follow-up, for follower like our countries, we have quite a limited constraint to launch the satellite. So in this way, we probably can launch like 20, 30, maybe 100, but less than far away from enough amount of satellite amount to cover our nation. So the cross-nation international cooperation that is so important to help every country have its independent satellite communication system, just like Polish, just like Mr. Ostapol just share the Europe have like GovSat, this kind of program. This is fantastic, and but unfortunately, it's only for European members right now.
Yeah, but then if we cooperate with Poland, sorry to interrupt, but Poland on the other hand is a gateway to Europe, right? So being a member of ESA, and not to mention the very recent use case that thanks to ESA satellites a few days ago, the movement of the let's say vessels has been discovered. Already. I mean, the exercises for invasion, right? So that was through ESA satellite images. So this is very practical examples from what a few days ago. It was 3-4 days ago, right? So then it shows very practically how this cooperation and exchange is vital for us.
Okay, thank you for your Thai VP Yang. You have shared us some information, and today meeting that all guest audience that you will know that the importance of satellite. Taiwan cannot have satellite because Taiwan is an island. So the satellite can have for disaster usage, and also for the redundant, and of course that for when the war happened between Taiwan and China, satellite is the only way that to connect to the world. So we need to use the satellite. But satellites will burn the money, 做了钱，做花开钱的啦。所以 not only one company, the country need to cooperate. So many countries need to cooperate together. So when you know the satellite, importance of satellite, 它这个 APSCC has a meeting in the November 4 and 5. Yes. So if you want to join the meeting to learn more satellite knowledge, you can go to the VP Yang and join the meeting again. Okay. Thank you. Do we have time? Time's up.
还有10分钟。
10分钟 Okay.
10 minutes.
So then the third part is that Q&A. If you have any question want to ask the 5 panelists, you can raise your hand. Anyone has a question for any topic, for any speaker? No? It's okay. Everybody is satisfied for this meeting. So let's question for the HAPS. You have mentioned HAPS, HAPS, right? What's the difference for the HAPS actually with the GO, BO, and MEO?
Yes, thank you very much for your question. So, my most important difference would be latency and maybe
Latency.
broadband aspects. So, due to the short distance between the hubs and ground, so maybe transmitting power of the RF optical or whatever, so transmitter, so can reduce the transmitting power due to the short distance, and maybe many aspects, many benefits. In addition, one thing to mention this, so hubs can be a stable, long duration, high resolution observation platform than LEO or MEO.
So HAPS is always on one country.
Yes.
Or it will move.
Yes, but
always on one country. For example, for Japan, the uptime space in Japan, coverage of Japan only, right?
Yes, coverage would be maybe 200 kilometers for one hubs.
Okay.
So, to cover whole the countries, for example, in Japan, maybe more than 20 hubs will be needed.
Okay.
But this can be a really stable, high-resolution observation platform. Maybe this will contribute to also space shift, maybe perspective, and maybe it to a high-resolution, something AI-based real-time, quasi-real-time, something detection or something from the Earth observation data, I think.
Thank you.
I can provide more information about hubs because as moderator mentioned that hubs is movable. Yes, it is movable because most of the hubs is we can set up it in a balloon, so you can move the hubs system to the area you need it. For example, we just have a disaster in Taitung, so if we have a hub balloon, so we can move our hub balloon to the area, then we can have the satellite signal to help the little area have a good communication system.
Thank you. 我们都知道那个 LEO、GEO、MEO 啦，就是说低轨，然后中轨跟高轨啊。那低轨跟中轨是会动的，它会绕着地球这样子跑哦，所以它要很多个啊。所以比如说那个 Starlink 就有9000多颗嘛，哦，那未来 Kuiper 也会有3000多颗这样子。那高轨是不会动的哦，所以通常就全世界只要3颗就可以固定哦，所以低轨的话，因为它 latency 比较low latency 啊，因为它会动，但是它距离地球大概500公里啊，所以很近，所以就可以运作了。那I use Mandarin to introduce the satellite for Taiwan。我说明一下，台湾的第一颗卫星是中兴1号，民国87年，那个中华跟那时候是中华电信跟sorry，it's okay。那时候我们跟新加坡新泰有合作了，所以它叫 ST5 啦，中兴1号，就是新加坡跟台湾的第一颗，民国87年，后来100年的时候退役，哦，那现在在上面那一颗是中兴2号，哦，中兴2号现在在 in service， 那是台湾第一颗卫星，那台湾 invest 40%， 新泰有 invest 的60%，所以那是台湾拥有的第一颗卫星，那现在还在运作上面，它是属于高轨，它那一颗会 always 在台湾上面的 in service 台湾 and Syntel only，所以它是高轨。那现在我们最近中华电信合作的OneWeb，它是本来是英国公司，后来被法国买走了，合并它现在全世界在低轨，它在绕的是大概是600多颗600多颗，所以我们叫 OneWeb 啦就低轨的。所以现在政府都在用中华电信这个，那我们已经开始商用，不过正式的商用服务给 corporate 还没开始，我们是给军政警消先真正给企业用户的还没开始，这个还在考虑军政警消要用多少，因为它毕竟频宽有限。那另外就是中轨，中轨我们是跟卢森堡一家叫 SES 合作，那它提供的频宽相对比较少，所以我们还没有正式拿到开放执照，所以我们还在努力。那最近炒得很热的那个 Kuiper 嘛，美国那个Amazon因为要跟上 Starlink， 所以它目前大概有900多颗，它预计会有3000多颗了，那现在正在努力，那可能明年 maybe 明年有机会可以合作，大概我先介绍一下。Okay, thank you very much for you today to participate, and I hope that we can learn some knowledge from our speaker. They are very, very wonderful speech for them. Thank you very much for you joining today. Thank you.
Thank you very much to our panel moderator, Mr. Chongyong Cha, the president of Chunghwa Telecom's Network Technology Group. If you could all come onto the stage for a photo, we're going to take that together. If you could stand up. Thank you again to our panelists. We have today's speakers, Morio Toyoshima at XGMF, Naruo Kanemoto of SpaceShift, Marek Ostafil of Sinotech, and Cha Kai-liu of CEO of DSP, and Paul Yang, the Assistant Vice President of Ubicon Technology. We have a few more photos to take.
Thank you. I see you.